Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.56 from the book Thermodynamics and Engineering Approach by CENGEL 9th edition. So the statement of the problem is 1 kilogram of water. Working fluid is water and mass is given to us as 1 kilogram. So mass is equal to 1 kg and working fluid is water. Fill a 150 liter rigid container. Volume is given to us as 150 liter, and 1 liter is equal to 1000. 1 liter is equal to 1 dm cube. So it means that 150 liter is equal to 150 dm cube. Convert dm cube into meter cube. So divide this by 1000, which is equal to 150 divided by 1000 cubic meter, which is equal to 0.15 cubic meter. And container is rigid. Rigid container mean that volume is constant, that V1 is equal to V2 is equal to constant. And so it means that V1 is equal to V2 is equal to 0.15 cubic meter, and mass is given to us as 1 kg. It means that specific volume is equal to total volume divided by mass, which is equal to 0.15 cubic meter divided by 1 kg, which is equal to 0.15 meter cube per kg. So V1 is equal to V2 is equal to 0.15 meter cube per kg. Now initial pressure of 2 megapascal, P1 is equal to 2 megapascal, and 1 megapascal is equal to 1000 kilopascal. So it will be equal to 2 multiplied by 1000 kilopascal, which is equal to 2000 kilopascal. The container is then cooled to 40. After cooling, final temperature. After cooling means final temperature is 40 degrees centigrade. Determine the initial temperature and the final pressure. Required is to find T1 and to find final pressure P2. So we start solution. First we find T1. So first we check whether the initial state is in mixed region or in superheated region. So from saturated steam table, at pressure P1 is given to us is 2000 kilopascal. Find Vf and Vg. So at 1000 kilopascal, 2000 kilopascal, this is saturated water table, this is 2000 kilopascal. So here Vf is equal to 0.001177 and Vg is 0.09963, 0.001177 meter cube per kg, and Vg is equal to 0.09963 meter cube per kg, and V1 given to us is 0.15 cubic meter. So as V1 is equal to 0.15 cubic meter is greater than Vg. This is 0.099. So the properties, so the initial state is in superheated region. This is temperature in degree centigrade, and this is volume in cubic meter, per kilogram. This is saturation curve. Now this is, let's suppose this is Vg. This is pressure P1, which is equal to 2 megapascal or 2000 kilopascal. So Vg is equal to 0.09963. Vg is equal to 0.099 meter cube per kg. But V1 is 0.1 more than this value. It means that V1 will be here. This is V1. This is 0.1 and V1 is equal to 0. This is V1. V1 is equal to 0.15 meter cube per kg. So it means that it is in superheated region more than this value. Now we will find T1 from superheated steam table. So from superheated steam table, at pressure P1 is equal to 2000 kilopascal and V1 is equal to 0.15 meter cube per kg. Find T1. So 0.15 is not available in steam table and 2000 kilo superheated table and 2000 kilo is available. So at P1 is equal to 2000 kilopascal V1, we will do interpolation to find T1. T1 is in degree centigrade. So if we check the superheated steam table, this is the superheated water table. So here 0. In volume, this is volume, 0.13857 and 0.15120 are available. 0.13857, 0.13857 and 0.1520. 0.15120. So but we have to find the temperature at 0.15 at 2000 kilopascal, and this is pressure of 2000 kilopascal. So in front of 0.13857 temperature is 350 degrees centigrade, and in here 400, 350 and 400. So we will find T1 between 350 and 400. This is 400 degrees. So by interpolation, third value minus first value, 0.15120 minus 0.13850 divided by third value minus second value 0.15 is equal to third value 400 minus first value 350 divided by third value minus second value. So if we solve this, so T1 will be equal to 395.24 degrees centigrade. So this is the temperature. Now we are finding final pressure P2. So for P2, first we find the final state of the steam. So from saturated steam table, at temperature T2 is given to us 40 degrees centigrade. Find Vf and Vg. So from saturated steam table at 40 degrees, this is saturated steam table and this is 40 degrees centigrade temperature. Here this is Vf and this is Vg. Vf is 0.001008. Vf is equal to 0.001008 meter cube per kg, and Vg is equal to 19.5229. 19.5 19.5225 9 meter cube per kg. Temperature volume is V2, which is given to us as 0.15 meter cube per kg, is greater than Vf and less than Vg. So final state is in the mixed region. Mixed region is basically liquid plus vapor region. So the pressure in the mixed region is saturated pressure, PS. Saturated constant volume prices, this is P, so constant volume prices will be this, such like this. This is initial, this pressure is, this is font 1 and this is font 2, and this is in mixed region, and here the pressure, this is pressure line, here pressure P2 is equal to saturated pressure. So we can easily find saturated pressure. So from saturated steam table, at temperature T2 is equal to 40 degrees centigrade, P2 is actually equal to saturated pressure, which is equal to, at T2 is equal to 40 degrees centigrade. This is saturated pressure, 7.384 kilopascal. 7.384 kilopascal. And this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.